Hello, I'm Aaron and I'm going to walk you through the first tutorial on how to use the South Australian Game Makers Association engine. What we're going to do is we're going to create a very simple game, and this game will serve as the platform and the base of all games, and all games can be done the exact same way. So we'll go into our favorite IDE, I use Eclipse, and we'll go into a SAGMA folder, into the source folder. Going down to SAGMA and we'll find a package called games, and in there are already two games, the demo game and the RTS game. These are just small little demos designed to showcase and designed to demonstrate the capabilities of the engine so far. So to create our own game, to put our game inside the engine, we'll right click games and create a new package, and this package will serve as a container for our game. Now we'll call our package tutorial1, and I'm sorry, I should do that lowercase. Packages should always be in lowercase, not camel case. And if we look at the demo and the RTS, we'll see that they've both got two files in it. They've both got the entry point main file, which is called the same as a package file, but in the right casing, and a configuration file. So we'll follow that pattern. We'll create a new class, and we'll call it tutorial1, same as the package name. It doesn't have to be. Good form. And we'll create another file in here. And this one is just, actually we'll just copy the configuration file across. So we'll copy this, and we'll paste it into ours. And we'll open it up for editing. Then we'll see it's got one line. It just defines which class is the actual entry point, and we can change that to tutorial1, which is what our entry point is called. We'll save that and close that and head back to here. Now in order for the engine to recognize it as a valid game, we need to register it as a game. To do that, we extend the game class. We'll need to import the game at sagma.core.render, and we'll also need to implement the initialization method, which is just this method here. And at this point our game is fully functional. We'll run the engine. Two ways to do that. There's a run button there, or we can right click the driver, run as a Java application, and that's the engine at the moment, and it's got three games, as you can see. It's got the demo, the RTS, and the newly created tutorial1. If we click on tutorial1, it will load our game, which has nothing in it, which shouldn't surprise you, but it's fully working, and you can see it loads just fine. The first thing we'll notice is that the escape key does not automatically terminate the application. We'll use the stop over here. To make the escape key automatically terminate the application, we have one simple line where we can put in the initialization, and that is set escape key to exit method. We'll call that, save it, and run, and we'll see after loading tutorial1 that the escape key terminates the application immediately. Now the first thing you have to think about when you're making a game is what type of game is it going to be? Is it going to be a three-dimensional world game, first-person shooter, or is it going to be a two-dimensional game? Now while you can get around doing this with the separate platforms, it is advised that you set the game mode of the engine to the right platform, two-dimensional or three-dimensional. And this can be done with the set game mode method. And it lists two game modes here, 2D and 3D. I'm going to demonstrate a two-dimensional application. I'll do that. It doesn't make any immediate changes, but if you change it later, you will notice the difference. Now we need something in our world to draw. So we're going to create a player of sorts. Now everything in the world, every object is an instance. So if we create a new player, it will be an instance, like such. And we'll need to import this from sagma.core.model Always import from SAGMA. And we need to make a new instance. So we'll call player equals this.make, and it'll automatically fill in the drawable context and the file name. The file name is a file name of what model we want to load. If we go down to here into the models directory, we'll see that we've got a choice of many models. Typically these should be inside your game directory. You should have another directory called resources and put your own models in here. But these are globally usable models. We'll pick the Fern because I like the Fern model. And we'll use the right file path. And we can do that just with models/fern.obj. It's quite simple. We'll run our application. And we'll see that we've got a fern in the middle of the screen here. Firstly, we see that the model is a bit too big, so we want to reduce the size of the model. So we'll call on player, and we'll set the size, and we'll set it to 0.1f. About the engine, it considers 1.0f to be half the screen, and it considers 0.2f to be the whole screen. That's the screen wide and the screen high. They are both the same thing. We'll save this and run it. And we'll see that our model has indeed shrunk. The next step we have is we want this fern to move across the screen. We want the capability to move. And we can do that using a keybind. Now every action and every property of your game should be dealt with in blocks of classes. And you'll see what I mean in a minute. To make a new keybind, we need a new class. And we'll call this the moveWrite class. And we want it to be a keybinding. So extend a keybind. And so we'll make a new inner class. And we'll import keybind. And we'll add the unimplemented methods. And we'll see that we've got 3 new methods that we can fill out for the moveWrite class. Before we get to that, we need to add the moveWrite class to the main collection. This.add keybind, and we'll create a new moveWrite instance. Now allow us to move right. Not yet, of course. Now, this is key. Basically says, am I or am I not a moveWrite command? All commands are situated in the key event VK sequence, and while confusing at first, it is very simplistic. So we'll check if the key is a moveWrite key. So if the key is the right key, then yes, we are a moveWrite key. We need to import the key event from Java AWT event. And we'll also have a second write key, and that's the D key in the WASD format. So if the key is a D key, we are also a moveWrite command. And you can see using this method you can do situational keys and dynamic key bindings very, very easily. All you need to do is change this line here, this one word here, to a dynamic key, and it will automatically update down the chain and correctly use the right key. Now when we press the key, we want the player to move, and we want him to move to the right. So we want the player to move, so we have to get the state of the player. That's all the information, all the position information. And we'll add a speed. Now this speed is going to be at 0.1 units to the right. So the player will move to the right 1/20th of the screen per step in the engine. We'll import the vec3. Now we'll use the same thing in key released. when we let go of the key, we want the player to stop moving, so we need to subtract the same speed that we just added. Pretty simple. Now we'll run the engine, and we'll see that our player is moving, unfortunately, up. And that's because we did it in the Y column, and not in the X column. I apologize for that. We'll run the engine again, and we'll see that the move right key now works just fine. Now move left is pretty much the same as move right, so we can copy the same template and put it down here. We'll change the class name to move left, we'll change right to left, the D to an A, and we'll swap the speeds around because we want to move left first and then move right when we let go. We'll run this engine and we'll see that the move left command does not work. That's because we have not added it to the engine yet. So we'll quickly add the move left capability to the engine. And we'll see now that the move left command does in fact work. And now we can freely move left and right across the board. Well, that ends tutorial 1. Well, and you can look forward to future updates where we'll do, the engine will do for you collision detection, and you'll be able to implement collisions, as well as other neat functions. And I look forward to doing more tutorials.